A string is wrapped over the edge of a uniform disk and the free end is fixed with the ceiling. So string is wrapped over a disk and the free end is fixed to the ceiling, something like this. So the disk moves downward, unwinding the string. So find the downward acceleration of the disk. So during this process, so tension is acting in the upper direction. We have gravitation force mg downward. It's a disk. And if you see this point string is not moving. Why this point of the string is not moving? Because it is attached to the ceiling. Hence this point has zero velocity. If this point of the string is having zero velocity, even this point will have zero velocity. Even the point which is just touching the pulley is also having the zero velocity. So if it is having zero velocity, it's also having zero acceleration. So I'm drawing the string separately. So this point of the string is having zero velocity and zero acceleration. Why? Because this point which is connected to the ceiling has zero velocity as well as acceleration. Now similarly, considering no slipping, even though if it is not mentioned, so assumption that there is no slipping between string as well as this pulley. So even the pulley should have zero acceleration. So if it is having zero acceleration and velocity, that is your instantaneous axis of rotation. So it's having zero acceleration and velocity is zero. So this is our instantaneous axis of rotation. So we can apply torque about Ia over as it is inertial. Inertial means acceleration is zero. So I am applying torque about Ia over. So mg is acting downward. So I write torque about Ia over is equal to moment of inertia about instantaneous axis of rotation into alpha. So torque, I write mg into r because tension torque becomes zero as tension is passing through the point of application of torque, that is it's passing through I over r, something like this. And this is equal to moment of inertia about I over mr square by 2 is center of mass plus it is at a distance of r, so mr square, parallel axis theorem. So alpha comes out to be 2g by 3r. So this is the value of alpha. But here it is asked us to find, in the question they are asking us to find acceleration of disk. Center of mass acceleration, it means acceleration of center of mass of the disk. So this is I over, it's a pure rotation about I over. So any point acceleration is distance into radius into alpha. So radius is r here, distance of center of mass from I over is r. So acceleration of center of mass is simply r alpha, which is 2g by 3 meter per second square.